Let's solve this question. So first, what you do here is you write out your parameters. So as you can see, we've written out our parameters. Our mass as 5 kg, distance as 4 meter, angle theta at 30 degrees, our coefficient of kinetic friction at 0.2, and acceleration due to gravity. Now if you check, we are not given acceleration due to gravity, but from the questions we know that forces are acting on it, and they are acting based on the weight, and when we are calculating weight, we are dealing with gravity, not normal acceleration. That's why it's being included. So next, what we do is we draw out our incline plane. So as you can see, it's something like this. Then we have 30 degrees here. We have, like from the questions, it says that there is a force dragging the object upward. So this is our force perpendicularly dragging the force upward. Let us call it force 1. And we know literally gravitational force drags this object downward. So let's call this force 2. And from the question, we are given friction that is taking this same object in the perpendicular way downward also. So we call this friction. Have it together. So what we do next is write out our formula. As you can see here, our general formula for work done generally is force times distance. Now, like I said, there are different forces are acting on this, and they are all on weight, on gravity. So you see, our first force here is actually pulling this object upward, acting against a natural force, which is the frictional force that is pulling it downward, and the other force pulling it perpendicularly downward towards the gravity. Now, for the first force here, our F1, we have general formula for force, which is F is equal to mass times acceleration. Look, like I said earlier, we are dealing with acceleration due to gravity, so this will be mass times acceleration due to gravity, which we have here. But then we have to consider our angle here, which is 30. Now, how do we get this sine theta? Why are we using cos or tan? You see, the direction of this force one is opposite the angle, and the object is on the hypotenuse. And sine, that goes with sine, which says sine angle is the opposite direction divided by hypotenuse. So since this goes with sine, we are going to use sine. So this will be times sine theta, sine 30, right? And similarly for the second formula, which is our mass times acceleration due to gravity. Now for this, why we use cos is that the force is adjacent to the angle, divided by hypotenuse. That's for cos, that's stand for cos. And now someone will ask, why are we using our friction here? The friction force is acting with our F2 here. In other words, pulling it down. They are both acting against F1. So to calculate the actual amount or the actual force of F2 as the force acting against F1, you have to multiply them together. So as you can see, next we multiply each of these. We have 5 for our mass times acceleration due to gravity times our sine theta, which is 0.5, so it 75, and we have 5 times 10 times 0.866, which is cos theta, times 0.2, which is our coefficient of frequency, to give us an 8.2. Now what we do next is we add up this force to give